Good evening, everybody. Oh, sorry, good morning, everybody. Video capture device, yeah. This should be working. All right, so let's see if we have anything more information. All right, so yeah, let's see if we have just popped out the chat and what else? Morning. All right, so I'm actually thinking of saving the projects from now on because the projects are going to be bigger, right? We are supposed to create new ones. Project one. Yeah, this is the code that we were working on yesterday. And we have written all the functions and we just need to orchestrate them in the main. So int main, and in the main int choice is equals to 1, while choice is not equals to 0. We got enter the choice once, right? Printf enter the choice. Right, printf. First we need to have a menu. Right, menu, then backslash n. One for creation, right, 0 for exit. It should work. Printf, printf. D ampersand choice. We are taking that, and if choice is equals to 1, shall we have a loop over here? We'll create the value. We're just on. Right. Right. This is the correct indentation. This is the correct indentation. Yep. Else if choice is equals to 2, printf 1 for insertion at beginning, backslash n, 2 for insertion at end, backslash n, 3 for insertion at specific position. What do you say? Right. Printf and choice. So in ch, if ch is equals to 1, right. And by the way, we are supposed to display that, right? And is create going to return you anything? Yeah, it is returning you something that is equals to create display. If choice is equals to 1, that is equals to insert at back, right. for all of these, yeah, scanf, person value, and person ch, printf, enter the value, scanf, percentile d, and person value. You need a ch and you need a value here. That is equal to insert at back. Is going to take that value as a parameter and display. Alright. And else if ch is equals to 2, that is equals to insert at end the value, display that. Else if ch is equals to play, that is equals to impose printf enter the position to insert scan of perception D and person POS, right? That is equals to insert at post. Is that the code or insert at specific? Yep, insert at specific. So is gamma value. And you are going to display that. Right. Okay, we have entered this one. As if choice is equals to 3. What do you need? You are going to need a ch again. Printf 1. Delete at beginning backslash n 2. Delete at n backslash n 3. Delete at specific. Printf and the choice percentile d ampersand choice, sorry, the ch. Right. ch is equals to 1, that is equals to delete at back, and you are calling the display function. Else ch is equals to 4, that is equals to delete at end, and you are calling the display function. Right. Else ch is equals to 3 in position render and the position for delete scan of percentile ampersand POS, that is equals to deleted pause What is the position we are deleting? At position we are deleting. And we will call the display function. That is it. This is the choice, and this is the close of what? This is the close of while, and now and we will return 0 at the end, and this should be working. Nice, the menu could be a little more interactive. Menu. Uh, so this will print out the menu, let's say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then it will create a new line. Right? And backslash n. You are going to need a new line every time. Every time, yes, sir. And a backslash n. And a backslash n. And a backslash n. Backslash n. Backslash n. That is a great code. Nice, right? Creation. Let's say 10. Do you want to continue? Yes, I want to continue. 20. Okay. Where were we messing here? If choice is equals to 1, right? While choice is not equals to 0, head is equals to, now let us ask ChatGPT what is wrong with this code. Okay. There are several logical and runtime errors. You are dereferencing null while temp is not equals to null. Temp of next. Mhm. What the heck? Okay, my code has these many errors. So let's debug them. Insert at end, okay. So when temp of next is not equals to null, okay. insert at specific. I is equals to 1, yeah. Off by one issue for delete at 10. At delete at specific, yes. Okay, we are not dealing with the edge cases here. Insert at beginning logic can be simplified. Let it be. Display output readability. Leave it. Use your input flow issues. Leave it as well. So there is something wrong with the create function in the main block. That is what we are trying to solve. So choice initially is 1. Do you want to continue? Yes, I want to continue. If that gave 1, it will need to come here and it will take the value and it need to create the value and it need to display. Maybe the display is failing when there is only one node. So don't write the display here. You can just write the display at the end. That should be working. It's 1, enter the value 10, we want to continue yes, enter the value 20, we want to continue yes. Enter the value 30, we want to continue yes, enter the value 40, we want to continue no, okay. 10, 20, 30, 40. So the display function readability should be improved. Okay, and we need to have a backslash in here as well for the menu. Okay, and in the display function, if you look at that, %d backslash t or %d points to, you can write that as well. Come on. Okay, the code's still running as well. Enter the choice 1, enter the value 1, we want to continue yes, 2, we want to continue yes, enter the value 3, we want to continue yes, enter the value 4, and we want to continue. So 1 points, 2 points, 3 points, 4. Okay, the problem that I found here is, let's just close this one. So it is where temp of minutes is not equals to new. Right, you can print that. And then you can print a %d temp of data. If this works, we can keep it or enter the choice 1 to the value 10. We want to continue. Yes, printing. Yes, into the value 30. We want to continue. No, right? That is working. Oh, great. Let us insert at specific position. Let us insert at end. What shall we insert? We shall insert 40. That's great. And we need to insert again. Let us insert at beginning now. Let us insert 5. Nice. And we need to delete. Let's say we shall insert again. Insert a specific position. enter the value. Okay. What value are we inserting? Let's say we are inserting 25 and enter the position at third position. Right, third position got inserted and we are deleting here. So at where are we deleting? We are deleting at end. That's great. And we need to delete again. We need to delete at the beginning. That's nice. And we will delete again. We will delete at specific position. What is the position we are deleting? We will delete at second position. Nice. I mean, wow. 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 So no complaints, man. No complaints. Yep. Yeah, that's data. And I'm going to save this project as right. You know what? I'll delete everything first. We got any comments? So we got no comments. Save programs. Delete everything. Delete. Yes, let us keep this file in editor. I will save this project as save programs, right? Saving link list. Saving it. So I need to save it. Will it get saved? Alright, save as um, win it as only link convention. So, yeah, when you run, is it lagging out? Okay, compile it and run. Yeah, everything's working fine. తర్వాత అయితే మాట్లాడు క్లాస్ లో ఉన్న తర్వాత క్లాస్ లో ఉన్న తర్వాత మాట్లాడుతుంటున్నానా all right, we have completed the single list and yeah, we are not going to the double linked list and all. I think now, are we? Okay. We are supposed to reverse the list, both iteratively and recursively. Reversing the same linked list. Right, so how do you do that? Let us try to formulate our own logic first, and then we will see. This is yesterday's. This is yesterday's analysis, right? Yeah, let's say we have something like 10, 20, 30, 40. So we need to do this 40, 30, 20, and 10. This 40 should point out towards the head. So what can we do? Let's just go through the code once. Recursively and iteratively in pair reverse list. It is taking head as a parameter. So previous is equals to null, current is equals to head. Okay. And next you will have a pre current and head while the current is present. Next is equals to current of next. Alright, current of next is equals to pre and pre is equals to current is equals to next. What the heck? So what are we doing here? We are taking 3 pointers, pre, current, and next. Pre is equals to null, and we are taking current, and we are taking next. Okay. And then what are we doing? Current, you are placing it as head. And then next is equals to current of next. That means, let's say, for the first iteration, previous is null, and current will store the address of head, that is 10. And next, we have not initialized it yet. So next is equals to current of next. What is current? 10. Current of next is 20. So next will become 20. And current of next is equals to pre. So current is another node. It will point out to, okay, what is 10 of next? What the heck? Oh yeah. So current of next is pointing to pre. That means current of next. Okay. I guess you are supposed to draw the entire list here, mate. So let us say this is 100, and this is 10, and this is 200. This has the address of 100, and then this is 20 and 300. Right. This one has the address of 200, and then this is 30, and this is 0. It is not pointing out to anything. So this is 300. So this is basically our linked list. And then what are we doing? We are, so initially previous is equals to null. Current is equals to head. What is head pointing to? It is pointing to 100. And next. So in the first line, you have written something like next is equals to current of next. So current of next is 200, right? Next is pointing to that. And then what are you doing? Current of next is equals to pre. So current of next. So this is current. Right, let us draw a node. The current is pointing to 10 and the address part is 200. So the previous null, it will do that. So this will become our last node. That's great. Current or pre is equals to current and current is equals to next. So pre will become current. So pre will become 100, that is current, and current will become next, that is 200. And then again next will be calculated based on current of next. What is current here? 200. 200 of next is 300. And after that, what will you do? Current of next is equals to pre. Is that what you will do? Next, okay, current of next is equals to pre. Is that what I said? Current of next is equals to pre. So 200, 200 of next. So this is the data. Okay, it is pointing to now. Let's see. Current of next is equals to pre. So what is pre? 100. So this is 100. This is 100. So it is pointing here like this. Actually, not like this because this is pointing to null. So this is not the case. Right. Okay, I need to wrap this thing around my head now. Right, let's try to understand this. First, we are having pre that is pointing to null, and we are having current that is pointing to head. So that is the first node, and that is then next. So, firstly, we are calculating next is equals to current of next. So now pre will be null and current will be 100 and next will be current of next, that is next part of 100, that is 200. Nice. And now what will you do is you will update the value of current. Update the next part. Update next of current. So how will you do that? Current of next is equals to 3. So reversing it essentially. If the current pointer is pointing towards the previous pointer, that means you are reversing it. Is that the case? Yes, it is the case. And now it will become 3 is equals to null again. And now current of next will point towards the next part, will essentially point towards the previous, that is null. So next will be 200. So what are you getting? You are getting a 10 node and null that is pointing towards the next node. After reversing, you need to update it. Update pre and next. Right? So pre is equals to current. What will it do? The previous node, which is null, that will become current. So previous will become 100. Actually, it is current of next. And okay. So what I need to do is I need to let the end. Are you putting the head or not? Pre is equals to current. Current is equals to next. You are just updating them in the reverse order. This is iteration, and we have something else also called recursion. Uh, Reversing a list, right? Right. Let me just do something fresh. This is 100. This is head, and this is data. This is the next part. This is the address of the current node. This is another node. Let's say this is our linked list, and essentially what we are doing is we are setting previous to null, and we are setting current here, and we are calculating next is equals to current of next. So this is technically the current node, and this is technically the next node. So what you are doing is, so current of next you are setting to previous null, right? There is something like prev is equals to null. So what you are doing is you are doing this current of next is equals to prev. You are doing this to null. So this link is essentially broken. And then what are you doing is current of next is equals to prev. After that you are right. Your current prev is equals to current. So prev, which is basically null before, it will become current. So this current is prev now. And current is equals to next. So this next, it is current now. How to how to make this thing stay, man? It is popping down every time. So this is next now. It will calculate next again. Current of next is equals to 3. After that, what we current of next is equals to 3. Yes. So you calculated current. Okay, now what are you doing? Current of next is equals to prev. So this is prev. Current of next, this is current of next. You are replacing this with the value of prev. So that is 100. Here it gives you something like 100. So a link will be formed from here to here. Wait. And prev is equals to current is equals to next. This will jump here and this will jump here. There is no next here. Okay, that makes sense. Prev is equals to current is equals to next. So this was prev before. And oh wait, damn it. Wait, dude, I didn't. Shh, I didn't click it that many times, man. Okay, so current of next is equals to prev. This is how that works, and then prev is equals to current. So this will become prev, and this will become current. Now you can remove them. I just got confused. All right. So now you are calculating next is equals to current of next. there is no next here. Next is pointing out to 0. And then current of next is equals to prev. This is prev. So 200. There will be a link like this. Right. And prev is equals to current. Current is equals to next. This will be our prev now and this will be our current now. So while current exists, right. Man, he's a man on the world. All right. So this is, and the loop is going to stay until the current exists. But now the current has become 0. So it will return. What will it return? It will return current. Is that it? Okay. No, exactly. That's what we thought. While current stays, here current did not stay. So you need to return the last node address. Last node prev. That's great. So this will be a pointer, the prev pointer. Right. So we are supposed to put that one now. And that is how you reverse a linked list iteratively. So how do you reverse it recursively? What is the base case if not equals to head or not equals to head of next? Return head. Okay. Struct node rest is equal to reverse recurse head of next. Head of next is equals to head. Head of next is equals to null return rest. Oh what? Wait. Yeah, we can code this. We are sticking to this right now. Or is hash include and state dot next. I can copy the code from the previous function, but I wanted to type. So let me type struct node in data struct node next. All right. So we created a new node. We need a head. We need a temp. We need a new node. We need a next. We need a preview. We need a current. I guess they are enough. Struct node create. What will it take? Int value. Right. Let's make that. Sometime D and person value. You need to declare a value here. All right. New node is equals to struct node and size of struct node. New need data value. New node next equals to null. So we need to initialize the head is equals to 0. If head is equals to 0. Right. If head is equals to 0, temp is equals to head. Head is equals to what that is equals to mu naught. Temp is equals to that. Else, if that's not the case, what are you going to do? Temp of next is equals to mu naught. Temp is equals to mu naught. Shall we write that here? Return it. And you need to write a display function here as well. So temp is equals to that. While temp is not equals to temp is not equals to null. Right. And the person data temp is equals to temp next. This is going to be a void function. Nice. We have created and now struct node reverse. What will it take? But node is going to take the value as head. Okay. So temp is equals to head. Do you need that? Okay, let's. We have created a next pre and current, right? So pre is equals to null, current is equals to head. And next. We got next already initialized, declared above. So nothing to worry about. So while current is going to stay, you are calculating next is equals to current of next. You have calculated next, and then what you are going to do. So current of next is equals to preview, and then preview is equals to current is equals to next, and at the end you will return preview. So void main and ch is equals to 1, while ch is not equals to 0. Enter the value. Yeah, what are the parameters that the create function is taking? It is taking that price. Enter the value scanner, person value, and person and person value. Come on, this is going to be value that is equals to create with the value and print as you input content and person value and person ch. So after creating your display and that is equals to reverse head and display. after reversing English written. So what do you say? Reversing sentence. A value is redeclared as a different kind of symbol. Okay, let's do some well. And the value 10. What? No, 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 no. What? Okay, it is taking value here. No number of data is equal to well, no number of action equals to none. So we just need to remove this one. Create. Okay, we don't need this one and ouch. So it will create since you are running a while loop here. Print the value. And present ID. Networks. And we want to continue. Yes. Nice. 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 Okay, dude. We have just learned how to do the recursion. Sorry, not the recursion, iteration. Always supposed to do the applications. So not at least assuming you're removing duplicates, polynomial addition using a linked list. Okay, wow, this is too much. Did we not do BST? Wow, we did not do BST, people. This is 11:10. Yes, I will take a break for 10 more minutes and we will come back again. We will come back again and what will we do now? We will do PST and behavior trace, right? PST both the insertion, creation, delete. Similarly, for AVL trees, we are doing all of this. And then we have something very fascinating called B trees. And then we have heaps. Those are the end of the data structures. Then we will get into something called algorithms. They are even more difficult, but as you know, we gotta do that. So should I keep this stream on? Yes, I should.